In this video, I will discuss a JEE Advanced PYQ from the topic waves. This question is based on Doppler effect of sound waves and resonance phenomena in an organ pipe which is closed at one end. Doppler effect relates the frequency of the sound emitted by a source and the frequency of the sound as received by the observer. Let the frequency of the sound that leaves the source be Fs, and let the frequency of the sound as it reaches the observer be FOB. The source can move either towards or away from the observer. Similarly, the observer can move towards the source or away from the source. So the frequency, observed frequency, is related to the source frequency by a factor C plus or minus velocity of observer divided by C plus or minus velocity of the source Vs. C is the speed sound in the medium, and the plus or minus sign can be decided based on the fact if the distance between the observer and source is decreasing, frequency will increase, the observed frequency, and if they are moving away, then the observed frequency will decrease. So to increase the observed frequency, you have to put plus sign here and minus sign in the denominator, because if the denominator is small, then observed frequency will move. To decrease the frequency, you have to put minus sign here and plus sign in the denominator. Another basic concept that is used in this question is organ pipe. Organ pipe is like a, say for example, cylindrical pipe of some length L, which is closed at one end. So there is air here. Not all frequencies can exist in this pipe. So the minimum frequency that can exist is will have a variation like this: node at the closed end and anti-node at the open end. Sinusoidal variation will look like this. So this is one complete wavelength. So from this node to the next node, it's half wavelength, and to the node to the anti-node, this quarter wavelength. So this is node here, this is anti-node here. So this much is quarter wavelength. So this is the minimum frequency that can exist. Let me call it lambda naught. So for this one, lambda naught by 4 is L. From this you'll get lambda naught as the wavelength as 4L. And you have this relation C equal to mu lambda, where C is the speed, mu is the frequency, lambda is the wavelength. So from this we'll get frequency as C by lambda is, for this particular mode, will be 4L. So this frequency, I can call it the minimum frequency that can exist, because it's for this particular node. The next higher mode that can exist in this organ pipe is same pipe, so it should be of same length, L, but it have a half wavelength or a loop and a antinode at this end. The boundary condition for organ pipe which is closed at one end is, at the open end there should be antinode, and at the closed end there should be node. So the next higher frequency is this one. This is one loop and then quarter wavelength. One loop is from 0 to 0 or node to node. So node to node is half wavelength. So this is from here to it's lambda by 2 and then lambda by 4. So lambda by 2 plus lambda by 4 is L. But this wavelength is different. So we call it lambda 1. So 3 by 4 lambda 1 is L. So lambda 1 is 4/3 of the length. Lambda naught is 4L. So in this particular mode, the same thing if I use here, I'll get the frequency as mu1 corresponding to this mode will be C by lambda 1, which is 4/3 of L. So comparing this thing with this one, mu naught is C by 4L. So this will be 3 times mu naught. So the minimum frequency is mu naught. The next higher frequency will be 3 times mu naught. So next higher mode which can exist in this pipe will be 2 loops and a quarter wavelength. So in this same, this one, there will be 2 loops and then there will be a quarter wavelength. This is 0, this is 1, this is 2. So here you have from here to here, you can consider as 2 lambda by 2 or lambda plus quarter wavelength, lambda by 4. So the next higher mode will have lambda plus lambda by 4 equal to L. So that is 5 by 4 lambda equal to L. This lambda is actually different from the first two cases. Let me call it lambda 2. So that will give me mu 2 as 5 times mu naught. So the frequencies which can exist in this organ pipe are the fundamental frequency mu naught and then odd harmonics. The next higher frequency will be 3 times the fundamental frequency and next will be 5 times. Next will be 7, 9. So all odd harmonics can exist in this closed organ pipe. So with this basic understanding, we can solve this JEE advanced question. This is the question, you can read it. A source approaching with speed u towards the open end of a stationary pipe of length L is emitting a sound of frequency Fs. The farther end of pipe is closed. The speed of sound in air is v and f0 is the fundamental frequency of the pipe. For which of the following combinations of u and fs will the sound reaching the pipe lead to resonance? Option A, u is 0.5 v, fs is 1.5 f0. Option B, u 0.8 v, fs 2 f0. 0.8 v, fs 0.5 f0. Option D, u 0.8 v, fs f0. You can pause and run this question. So there is a source which is emitting sound waves of frequency Fs and it's moving with velocity u towards a stationary pipe which is closed at one end of length L and fundamental frequency is f0. Sound speed is v. So I have used symbol C for sound speed. So sound speed is v. So this sound, as it reaches this stationary pipe, its frequency will be different. Let me call it Fs prime. Because the source is moving, the frequency will change either because of the source moving or the observer moving. So this Fs prime is related to Fs by a factor C, which is the speed sound v, plus or minus velocity of observer. Observer is this stationary pipe with 0 divided by c sound speed plus or minus velocity of the source, which is u here. Since the source is approaching this stationary observer, which is the pipe here, the frequency will increase, so the denominator has to be less. So it should be minus sign here. So the relation between the observed frequency at the pipe location and the frequency of the sound emitted by the source is multiplied by a factor v by v minus u. V is the sound speed, u is the speed of the source. So this multiple choice questions, now we check each and individual options. So option A is 0.5 u. So for option A, u is 0.5. So this will become 1 minus 0.5, it's 0.5. So it will become 2 fs equal to fs prime. So this is the sound frequency when it reaches this one. So if this 2 fs matches with this, the frequencies that can exist in this pipe are f0 and odd harmonics. The next higher harmonic is 3f0, next will be 5f0, and so on. 7f0, 9f0, 11f0, like that. So if this 2fs, which is the frequency of the sound as it reaches here, if it matches with either f0 or 3f0 or 5f0, then there will be resonance. So that means fs should match with this 2fs, f0 by 2 or 3 by 2 f0 or 5 by 2 f0 and so on, 7 by 2, 9 by 2. So this is matching, fs is matching with 3 by 2 f0. So this particular condition, there will be resonance with the first harmonic. So option E is true. Option A is possible for resonance. Option B, U is 0.8 B. Option B, U, which is the speed of the source moving towards the stationary pipe, it's 0.8 B. In that case, the frequency of sound as it reaches the pipe will be Fs prime will be different from Fs by a factor V by V minus U. U is 0.8, so it will be 0.2. So 1 by 0.2, so that is 5 times Fs. So the frequency of sound has increased 5 times when it reaches this pipe location. So if this 5 Fs matches with F0 or 3F0 or 5F0 or 7F0, because all these fundamental frequencies and this odd harmonics can exist in this pipe. So if this frequency matches any of these frequencies, there will be a resonance with that particular frequency. 9F0 and so on, all odd numbers. So that means Fs should match with 1 by 5 F0 or 3 by 5 F0 or 1 F0 or 7 by 5 F0 or 9 by 5 F0 and so on. So option A, U is 0.8 B, so Fs is 2 F0. Fs 2 F0 means it should be 10 by 5. 10 by 5 is not possible. Next will be 11 by 5 F0 and 13 by 5 like that. So Fs should matches with 9 by 5 and 9 by 5, not 10 by 5. So option B is not possible. Because option B says it should match with 2F0. 2F0 matching is not possible because for that we need 10F0 here. Option C, it should match with 0.5 F0. 0.5 F0 means It should be here. It should be 2.5. If it is 2.5 F naught is possible, then Fs will be 0.5 F naught, which is not possible. So option C is also not possible. Option D, for u equal to 0.8 V, Fs should be F naught. Fs will match with F naught, so resonance is possible. Fs matches any one of these things, resonance is possible. So in the fourth option, Fs is equal to F naught, so resonance is possible. So for a condition given in option D also, resonance is possible. So resonance is possible for option conditions given in option A and D. So there is a source with emitting sound at the frequency Fs moving the velocity u towards a stationary pipe of length L. So the frequency that can exist in this, the frequency of sound as it reaches this stationary observer will be given by this Doppler formula. So here this observer is stationary, so VOB is 0, and source is moving the velocity u, so u will be here. And since source is moving towards the observer, it will contribute to increasing the frequency, so it should be V minus u. Numerator V will be 0. So this frequency is written to the source frequency emitted by the source as this factor. So option A, and the frequency that can exist in this closed organ pipe is F naught of this type, antidote, and then this one. So quarter wavelength. Next higher is one loop and quarter wavelength. So you see that we get this result. Fundamental frequency F naught. The next high frequency will be thrice of the fundamental. Next high harmonic is 5 times the fundamental. 7, 9. All odd harmonics can exist. So option A, U is 0.5 V. So from that, we get the frequency of the sound as it reaches the pipe location will be multiplied by this factor. So U is 0.5 V, so it will become 2 Fs. So this 2 Fs should match with F naught or 3 F naught or 5 F naught and so on like that. So when 2 Fs matches with 3 F naught, Fs is 1.5 F naught, which is given in option A. Option A, the condition is U is 0.5 and Fs is 1.5. So when this condition is satisfied, resonance is possible with the first harmonic. So option A is correct for the resonance condition to be satisfied. Option B, U is 0.8 V. For that, the frequency of sound as it reaches the pipe will be multiplied with this factor V by V minus U. V minus U is 0.2. So it will be 5 times Fs. So the frequency has increased 5 times when it reaches the pipe. So this 5 Fs matches with F naught or the first harmonic, 3 F naught, 5 F naught, or 7, 9 like that. Resonance is possible. So when 5 Fs matches with 5 F naught, that is Fs matches with F naught, resonance is possible. That's given in option D. Option D, for U equal to 0.8, Fs is F naught. So Fs equal to F naught will give resonance. Option D is correct. For option B, it should match with, Fs should match with 2 F naught, which is not possible. For Fs to match with 2 F naught, this should be 10 F naught. 10 F naught should be there, but only 11 F naught is there, 9 F naught is there. So option B is not possible. Option C, Fs should match with 0.5 F naught. 0.5 F naught means 2.5 F naught should be possible. That's not allowed. So option B is also not true. So correct options are A and D.